Welcome, everybody. This is the community meeting for OpenFGA in June 2024. And today we have a few things that are kind of interesting. In particular, we're going to have some people from Canonical showing how they integrated OpenFGA in one of their products. I'm really looking forward to it. And an agenda will be structured in the way it always is. We kind of short introductions if someone wants to introduce themselves. It's the first time they join the meeting. And mention a few things we shipped, do a few demos, then talk about the future and what's happening in the community. So this is our team, and we'll be growing it hopefully in the next couple of months. So we probably need to create another slide, or the names were going to become unreadable, but that's good news for us. So we are usually in Slack there, so you can reach out to us whenever you need us, the CNC of Slack. And we are hiring, or will be hiring on the team. So if you're interested, let us know, okay? And just ping us in the CNC of Slack or LinkedIn. So if anyone wants to share something about you, like if the first time you're joining the meeting, introduce yourself and share what you're doing with OpenFGA, that will be great. So I think most of the people in the call have already been here for a few times, but if you haven't, so go ahead if you want.
Hi, I can start. My name is Mark. I work for Canonical in the LXD team, and we've been implementing OpenFGA, which we'll share with you very shortly. In terms of where we are in our adoption journey, we have integrated it with our product, as you'll see, and we're just ironing out a few more bugs now. So yeah, we'll get through those as soon as possible.
Awesome.
Yeah. I will go next. So I'm Maria Sara Alessandri. I'm the engineering manager of LXD and MicroCloud. And yes, we are looking at OpenFGA to implement our fine-grained authorization mechanism in those two products. Probably we will need to integrate more, but for now we can present how we integrate with those two. Happy to be here and to meet the community.
Thank you, Maria.
Hi, I'm Chris, and I work for Pilabs, and we're looking at using OpenFGA in our product range for better authorization rather than doing everything in-house.
Sounds like a good idea.
Hopefully we can help there.
Hi, I'm Gulin. I'm a senior engineer at Docker on the IAM team. I've actually met that team a couple of times, but this is the first time joining the community meeting. We have started using OpenFGA like quite extensively in our system, and hopefully in a future meeting we can demo that.
Awesome. That will be great too. Okay, so thank you very much. And let's start with things we shipped. So we shipped a new version of OpenFGA 1.5.4 that has an experimental flag for enabling a feature we are calling list users. We've been working on it for a while. We are almost ready. And we're going to share some details of some changes we're going to do after we learn about the behavior of the feature in some use cases. And the other thing is, if you're using JetBrains or any IDE from JetBrains, you can now have support for editing FGA models and with validation and coloring, whatever. So there's some people from Pauline's team, Jan, helped us build that. So thank you for that. And that it's been out for a few weeks already. So let's start with the demos. So we are all willing to and waiting for understand how you're using it for the LXD. So take it away. I'll stop sharing and I'll let Mark do it.
All right, so we already done the presentation, so let's start with the presentation. So we are going to present how we integrate OpenFGA and implemented our identity and access management solution in MicroCloud and LXD. So next, please, Mark. a short introduction. I will give a short introduction to microcloud and LXD because maybe not all of you are familiar with those two products. And then I will give the floor to Mark, who actually designed and implemented the identity and access management solution in LXD. There will be a short demo and then time for questions. So you can put question in the chat or ask live at the end of this presentation as you prefer. So next, please. What's microcloud? Microcloud is a low-touch open source cloud solution. It's composed by different canonical products for the virtualization layer, for the storage, and for the network. It's automated. You can deploy it in minutes with a single command. It's simple, scalable, easy to scale as your needs grow. It's low touch, self-healing, little no human interaction. It's cost effective because there is LTS release and it is covered by the Ubuntu Pro subscription, and it's built with security in mind. And we improve our security posture implementing a fine-grained mechanism, authorization mechanism with OpenFGA. Things you can do with microcloud: you can do lightweight system containers or traditional VM. You can manage them through CLI, REST API, or the web UI. Project for multi-tenancy, profile for advanced resource control, hardware pass-through, snapshot, backup, image transfer, and live migration. I can't go into details for time reason. I want to give more room to Mark, but if you are interested in you can ask questions at the end or offline, of course. So next, please. As said, microcloud is composed by different canonical products, and the heart and where we integrated OpenFGA is the LXD. LXD is the virtualization layer component, and you can run on top of LXD Linux container based on LXD. And virtual machine in a unified user experience and with a minimal overhead. So next, please, Mark. This is an overview of the microcloud architecture. So as I say, there are different canonical products. So LXD for the virtualization orchestration. For the networking part, we have MicroOven. For the storage part, we have MicroSeph. MicroOven and MicroSeph are cousins of Oven and Ceph projects. They are low touch, easier to deploy, a little bit more opinionated. And everything is built on top of Ubuntu and Snap, and it's under the Ubuntu Pro subscription. Next, please, Mark. And this is a typical microcloud architecture, minimal architecture with 3 nodes. And as you can see, there's an LXD component, a MicroOven component, MicroSeph that spans across the cluster and local storage. Keep in mind this architecture because it helps to understand some design decision. And now I'm done, and I give the floor to Mark.
Great. So just before I go into the actual integration, I just want to give an overview of how access control was implemented prior to the addition of OpenFGA. So this is pre-521 release. So it's absolutely critical that LXD has some form of access control. And one of the main reasons for that is because privileged containers or system containers can be set up so that they have access to, essentially to the entire host. So, you know, that exposes an awful lot of risk. It's very easy to escape a privileged container and gain root access. So authentication is performed with mutual TLS in LXD. And to do that, the LXD server has a trust store of client certificates. And those resources are kind of server level resources. So you have certificates and storage pools that are kind of, you know, cluster wide. But most resources in LXD actually live within a project, and instances, for example, live inside a LXD project. So the way that access management was performed prior to the addition of OpenFGA was to restrict certificates to a subset of projects, and then projects themselves can be limited so that they can be restricted so that, you know, creation of published containers was not allowed. The problem that we had was that although OIDC authentication was added to LXD, we didn't actually have any way of managing the permissions of those users. And so essentially, they all just had root access to the LXD host. So we needed a solution. So we needed a new solution for access management. It needed to be agnostic of the authentication method, so it needs to work for both TLS and for OIDC and for any other authentication that we might add in the future. We needed to be able to give more restrictive controls or more control to an administrator on which types of actions can be performed on specific resources. So the TLS, restricted TLS user might have access to a project, a single project that might be restricted, but they were still able to create, edit, delete any resource that was in that project, and which is not fine-grained, of course. Must be compatible with existing TLS authorization. So we needed to have an easy mapping between the current TLS users, but just for backwards compatibility with older versions, and so that we don't downgrade anyone's existing access when they upgrade. And the last thing is probably one of the most important and difficult aspects of the way that we designed this feature. It needs to work out of the box. So if we just go back to this diagram, which Maria showed us earlier, these nodes are bare metal nodes. And so we need to ask ourselves, well, where would we actually deploy OpenFGA? And where would we deploy the database, which actually contains the tuples that OpenFGA relies on? And we don't necessarily know how our customers are going to set up their environments, especially for edge workloads or air-gapped environments. We don't know what compute power they have. You know, for example, imagine this is 3 Raspberry Pis. Where would you deploy OpenFGA in this scenario? So, how do we go about achieving these aims? In the first case, it was very simple. We just needed to generalize our concept of a client or an identity. So we just generalized that. We said all certificates are identities. They are certificate identities, and they already exist in the database. We just did a small translation there. The next step was to actually start storing our OIDC authenticated users in the database. So the way that works essentially is as soon as someone logs in, LXD will validate their access token or identity token. And then the first time they log in, they are stored in the database. From there, we can start assigning permissions to users. So next, users can be restricted to specific actions on instances and resources. And this is where OpenFGA became very, very powerful, of course, and had a lot of fun performing all the modeling for this. So essentially, all I did was map the LXD API to specific entitlements in the model, specific relations. And so in this instance, this endpoint allows you to run a command inside an instance. And so create an identity type and have a relation canexec that applies to an entity on an instance. These are very, very fine-grained relations, so they only apply to that particular endpoint. And having canexec doesn't imply that they can view that same instance. Next. So yes, being compatible with existing TLS authorization. Again, here, this was a modeling task. And the way that this is done is by modeling more of the LXD API. We have a kind of top-level resource called a server, which can be childed or have a parent-child relation with another type of project type. And through this, we can model we can map the existing TLS access to our model. And so here, a server admin or an identity that has relation server to the server, relation admin to the server, has full access to LexD. They can, you know, create and edit projects. They can create instances that are privileged, etc. But the an identity that has the operator relation to type project has the same level of access as a restricted TLS certificate. So they are able to create resources within that project, but they can't edit the project itself or change its settings. And again, we have the CanExec relational instance there just to show that that's the finest grain level of entitlement. And so the last thing is having it work out of the box. This is quite tricky to do, but the way that we ended up doing that was to import the OpenFGA server, just importing the code base and running it directly in LexD. And this allowed us to actually implement the OpenFGA data store interface. And thank you for structuring it so well that I was able to do this. And basically, we have it call our backing DQLite database. And so the good thing about this is that we don't need to keep all of our resources in sync with an external database. Everything's already there, so we don't actually have to implement any writing. Instead, we just need to implement reads. So we have a few tables that are of particular pertinence to this. If we want to list, for example, the tuples that are related to a project that have a related to a particular project by the project relation, then we can just list all of the, say, instances in that project. But when we want to get particular entitlements, we can find out group membership by just basically the identities to group relationship table here in the top right. For permissions, the way that these are structured are so that the entitlement column in the auth groups permissions table there is exactly the entitlement that you'll see in the model, or the relation that you'll see in the model. The entity type tells us which resource, LexD API resource we are interested in, and the entity ID is the actual ID of that resource in the database. And that's it. So time for demo. Can everyone see this okay? Good. So in the left-hand side here, I have a LexC client that is configured to talk to LexD over OIDC. So LexC. So I'm using an OIDC remote, and that's my current remote. In the right-hand side here, I have just aliased LexC to use this flag, and that means that it will always have root access, essentially. That's going to use the Unix socket to interact with LexD. So one of the APIs that we added was a permissions API, so the permissions can be browsed. And this gives you an awful lot of information. So these are all the resources that are currently in my LexD. Sorry, it's not shown very well here. So we have entity type server that lives at the top of the tree in our model. And there are a bunch of different entitlements that you can grant to against the server entity type. Groups, identities. Here's an instance, for example. And these are the entitlements that can be granted against that. So let me just clear this up. So let's see auth group list. So I've created a group here just to show how all this works. And in LexD, no permissions are granted directly. You would have to be a member of a group. And I'm a member of this group. So this group has me as an identity, and I'm an OIDC identity. So we can start to add permissions to this group, and they should show in the left-hand column. Let's see, permission add demo group. So I'll just show briefly on this side. I can't see any instances, but you can see that there is actually an instance in the default project. So we can do permission add demo group, and I'm going to add it to an instance. The instance is called C1. It's a can view, and it's in the default project. You can see that we can now view the instance. Of course, I can't do anything to the instance. So if I try to do, for example, let's see, edit C1. I forgot the name. Let's see, config edit C1. Let's say I try to add some config to this instance. Then we just get a forbidden error. I'm not allowed to edit the instance. Let's add more permissions to myself. So auth group permission add demo group project default operator. Let's try and do the same thing again. So I'm now able to set the config. I can also launch instances now. And I can edit them, etc., etc. And that's about it. Do we have any questions?
Yeah, Carlos, go ahead.
Yes. So first question, and it actually is a result of the last bit that you did there. Operator isn't necessarily a fine-grained permission as we would necessarily like as you kind of indicated with can view or can edit, right? Yeah. So there that would map up more to a role. And so you never really got into the details of how you expressed roles in your FGA model, because I would assume operator is on a role which would kind of map up more to a well, you either express that specific role as a special type of relation and then declare all the operations that that relation also implies. Can you go into detail about that?
Yeah, sure. I mean, that was part of the modeling that we did. Essentially, we've added some built-in roles to our model so that they are they can be accessible, or so that they apply to multiple fine-grained relations via just computed relations. So I can bring up the full model potentially and show you some of how that works. Am I still sharing? Oh, got the wrong.
Yes. And I ask this question because if it's a special type of role, that makes sense. But like when you start having to deal with like custom roles, if most of the OpenFGA relationship or OpenFGA documentation doesn't really, it identifies to kind of express those as the specific grants that role gives you, and not the role itself. So you kind of explode out the specific grants No, that's not the word, but
well, I can just give you an overview of how we did the modeling. So the model you can see is actually quite extensive. The server operator here, the project operator is defined against the project, and then you can only have a direct relation between an operator and a project. For direct relation between an identity, service account, or group member to a project. And this grants you permission to create, view, edit, delete all resources belonging to the project, but does not grant permission to edit the project configuration itself. And so you can see that in say an image, we define project, and these relationships between images and projects have to be handled by the storage driver. So those tuples are kind of extracted from the storage driver by the project that the image belongs to. And this can edit images is implied through the operator permission on project. So you can edit an image if you either have a direct relation, or if you have can edit images from the project above it. And you would have can edit images. Whereabouts is it? You'd have can edit images if you are an operator of that project, or if you can edit projects from server, and so on and so forth. And so it all propagates back upwards. And that was the only way that we could figure out as to how to be able to grant a single relation being server admin and have that propagate to grant you access to every single fine-grained permission in the whole system.
Pretty cool, yeah. And if you see there, Carlos, what they are doing is in every relationship, you can specify a fine-grained permission for that. So for example, a specific identity can edit images, or you inherit that from, in this case, the server or whatever you have in the hierarchy, right? So at any level, they let you specify that specific relation, or you inherit from the parent, right? And I think they're doing it across the hierarchy, right? So they can combine roles with very fine-grained permissions if needed in a specific resource.
Right. But in that case, it is a special role. Like it's a special relation that is indicative of a role, right?
Yeah, we call them built-in roles.
Yep.
Right. And do you have the problem of custom roles with LXD?
Custom roles, I mean, no, we didn't build roles into it essentially because we feel as though the majority of the roles have been covered by the ones that we've built in. Any use cases that we could think of, essentially, we've built them into the model. So, for example, if you wanted to give someone access to a single instance and be able to, exec into that instance but not be able to edit it, then we've got a built-in role for that somewhere. Oh God, not the easiest to see. There we go. So we created this built-in role for an instance user, and they are able to exec into an instance. They can access the console, access files, etc. When it comes to creating, I don't know, more custom roles, I would say for us, you would just create a group for that. We might create have roles in the future and expand that out, but I think for now, I think groups is sufficient.
I have a question. When you shared the schema, the DQLite schema that you were using, right, and the way you build the adapter, can you go back to that slide?
Yeah.
So is this the schema that you implemented the OpenFGA data store interface on top of? So these are the tables that you have. Okay.
Yeah, I mean, well, it's using a lot more than that because it needs to figure out, I suppose one of the key things which I didn't include in the presentation is that the way that we're defining our tuples is you'll have the entity type on one side of your colon, like an instance, and that maps directly to the entity type in the auth groups permissions table, and that tells us which tables we need to query. But on the opposite side, so like the tuple, the identifier for that particular resource is the full URL in the API. So it means that we're always able to find whatever that specific resource is in the database as well. So we're able to figure out its ID from its URL, and then we can, propagate that up. So it uses the whole data. It uses the whole database basically. It uses the entire decolite database.
Yeah, we might want to kind of follow up on this one, because you're not doing something that we weren't expecting, right? Which is kind of mapping the storage adapter to whatever database schema you had, right? And then build or use OpenFGA on top of that, which is pretty cool. And that you each time you open source something, there's always people using in a very creative way, right? And those are kind of very opportunities for us, right? So and also when we are discussing now some changes in the storage interface, then we're having like a conversation about the best approach. And I think this use case can give us also some light of the trade-offs of the changes, the trade-offs of the decisions we might be making on when changing the adapter. So great. That's pretty good information. Thank you.
Yes.
Thank you very much. I mean, it's been a pleasure to learn about this and to implement it as well, and a challenge. But yes, absolutely. I mean, the key reason why we needed to do it this way is because we had kind of three options going into this when we came up with the design. The first was, do we create some kind of internal VM and deploy OpenFGA and Postgres to that and run it? And that comes with the headache of managing it. And then how do we always know that we are running a reliable version of Postgres that's always going to be highly available? And then that becomes a management headache. The other option we had was to always enforce that the OpenFGA server would be external. We've left room in our spec to allow that still. So we would more than likely be like syncing the tuples from our internal store into that external database, or doing something similar. This hasn't really been rolled out a lot. I don't know how many users are really using this yet, so I'm really excited to see this kind of the uptake and figure out more bugs that I'll probably add as we go. So yeah, thank you very much.
Yeah, just to complement, of course, we are rolling out this usage. Very much interested in feedback, and we leave the room also for external implementation, because maybe enterprise have their own authorization, IAM, IDP, and then they want to keep them separated from microcloud. But for now, we integrated, even embedded, but we leave room for improvement and additional use cases. And we are here also to ask for feedback and suggestions. So thank you for letting us to be here and present our work.
Pleasure. Jigar?
I had a question, please, Mark. Do you have a need, or do you have a use case where one users could have multiple identities, like multiple identity types? Like I don't quite understand what the identity type value is. It like an email address or a internal ID? But what if you had a need to map multiple of these identities for just one single user?
That's quite interesting. So you would say that perhaps it's the same user that has multiple email addresses that's logging into the same server. I mean, in that case, I would say if it's a different email address, it's a different user. We did think quite a lot about what we should use as an identifier. And so for TLS users, that's the certificate fingerprint of their public cert. We were going to use the subject from the OIDC ID or access token. But then we had some discussion with the identity team at Canonical, and it's I mean, I didn't know how this could work, but apparently it's possible for that to change for certain IDPs, including Keycloak as well. So we ended up just going with the email address as being probably the most consistent thing, and you're likely to have the same one within an organization. Yeah, and I suppose if you did log in with a different email address, you can just be added to the same group.
The reason I asked this one is on our side, we run into this issue. We are a SaaS company, so where our customers' employee could have multiple external identities. Like they could have an identity in Google, they could have it in MS Graph, and their permissions, and we have to map their permissions to resources, and we have to use the specific external identity for that system. But when we have a user's context, it starts with an email address. So we resolve that to the external identity and then look up an OpenFGA. So it's a two-hop process.
I don't think that we would necessarily have that problem. Well, I suppose we might do. I guess one thing that we've not really seen yet is, when we've done a lot of testing for this, we've been using an IDP, and I've just been using password authentication with Auth0, but we've not had to deal with an awful lot of social logging. I don't think that with XD being an infrastructure tool that would be used extensively, but I mean, within a company that's using Google Workspace, for example, we don't know what's going to happen. So we'll cross those bridges when we come to them, I suppose.
Jared, just to jump in here a bit. So you mentioned you do that mapping before going to FGA, but why not have that mapping in FGA? So you can have an identity be a parent of another identity, in which case you can start merging identities.
Oh.
So,
I have not considered that. I would be curious to consider that, especially with respect to data. I don't know if it'll take one extra doing checks. So, okay, I'll definitely think of it here to see how we can model this. But that's a very interesting idea. Thanks.
Carlos.
Oh no, I was just going to comment because I've had to deal with that. I had to make the distinction between the concept of an identity, which I often refer to as the in-flight credential, and then the user or / profile, depending on what your application wants to call it. So that allows you to have all your permissions associated to the user, which is your local, kind of like the identifier for that user in your own system. And then you have an identity, which can be what in this diagram is the combination of the identifier for that identity plus their authentication method, and maybe a few more other details. So that way you have the ability to have, let's say, that administrator account where you want them to be able to use their SAML authentication or OIDC authentication. But if they ever have an issue with that provider, for whatever reason, you want to be able to give them local access as well. So they're the one user that can log in with their username and password. And so you have different identities for them with different authentication methods. One might be username and password, one might be OIDC, but they all map to a local user. And that's what you assign all the permissions and group assignments to. So you have a one-to-many relationship in that circumstance. And it's not easy to come back from that. That's one of those choices where you kind of have to make it early. Otherwise, things get really, really hard. And if you don't think you're going to have the need, you might want to rethink it, because especially with these kind of tools, you may want to plan for the future, even if you don't need it, because that local authentication and also enterprise type SSO is the one that we got bit up with a lot.
I guess for us, there is still always the option of there's the local Unix socket, which is always running. So if you are an administrator that probably set up the machines in the first place, then as long as you have SSH access to the machine, you can still access LXD. But it does sound like there might need to be another layer of generalization above identities in case these kind of problems do occur. So yeah, we'll think about that. Thank you.
Sounds good. Thank you very much. So we're gonna go to the next demo. We are running out of time, so we're gonna keep it short. But Rag, are you gonna show that one about the consistency options? Okay, yeah. So go ahead.
Hey folks, this is gonna be a short demo, and it's also thanks to Jim, who's not with us right now, like not on this call, but he's the one who did all the work. So I'm just the messenger here. We've had a ton of cases where, you know, caching improves latency, which is something we really care about. But you may come across a few cases where, you know, you want to suffer a bit on the latency side in order to get more on the benefit more on the consistency side and like get a fresher result. And this is like our first foray into this. So we're planning on going deeper and deeper into this. But our first, like, this demo is going to be extremely simple. First of all, we spun up an OpenFGA. We just turned on these two things. We first enabled the cache for check, and we enabled an experimental flag for consistency options. So OpenFGA should be running here. Second, we created a store with this model. It's like a very basic Google Drive sample. It has no tuples in it, so it's empty. And we're gonna go through quickly.
Are you showing the model somewhere?
Oh, sorry.
See in the developer screen. Yeah.
Yep. Let me share the entire. Is this better?
Yep. Can you zoom it a little?
Yeah.
Thank you.
So this is just the normal model, and as you can see, we have no tuples yet. We're gonna walk through this script. Quickly, what this does is we're gonna check if this user has access to this roadmap. Of course, we expect false because there's no tuples in the database. Then we're gonna write the relation. So we're gonna say, okay, this user is now a viewer, therefore they should be able to read. However, we're gonna check again quickly, and what the result will be is false. Here where you see this consistency minimize latency, this is the default. This is the current behavior when you have caching enabled. Like this is a default behavior always, but if you have the caching behavior enabled, this will go through caching. Therefore, to minimize latency, instead of going directly to the database, we would have cached the response of the first check for 10 seconds or whatever you have configured it to, and it will return false even though we had just written the new tuple. We're just gonna try again, and with consistency, this new parameter saying, okay, we want higher consistency, you will see it return something else. Surprise, I'm not gonna tell you what. Then we're gonna delete the relation and go through that again. So just, yeah, quickly. You'll see here, first of all, we checked, returned false. We wrote the tuple, and then checked again, it returned false. I wish I was printing here the latency, but like this would be really fast. It's not even gonna go to the database, it's just gonna go to in-memory cache. And then when we choose higher consistency, it's gonna skip the cache. We plan to iterate a lot more on this. So it's not just about cache. We're gonna try to be like, if you have caching in memory, if we support caching externally at some point, we were considering having caching in the SDK supporting that. So we're going to play around with those. So in terms of when you want to minimize latency, it's going to use anything like caching at the data store layer. If let's say you're using something like DynamoDB, if you choose higher consistency, it's going to try to skip all those and like try to work more. At some point, we may have more options. At the moment, we have these. We're also, Andres, do you want to talk a bit more about like going into the right tokens, or we don't have time now?
Yeah, no, so I think, yeah, we probably need more time to explain the full story there. So yeah, this is something we're working now. We already have like our first iteration of this, right? We need to ship this and include it in SDKs and in all of the tooling before it's ready. But hopefully it won't take us a lot of time to wrap it up. And so I think that's pretty much. I cover a few things that just might be worth mentioning before we wrap up the call. I'm gonna go quickly over this. So we're gonna be shipping list users pretty soon. There was a feature in the product, in the API called list excluded users. That the idea there was if you shared, we have this feature that is called public access. So you can assign that this specific relation is assigned to user wildcard. That means any user can view it. And when you combine that with but not in a list, it could happen you say, okay, every user can view it, but the ones that are not here, okay? So that excluded user set parameter that we returned had the list of users that were excluded. We found a lot of edge cases there that wasn't clear what the return value should be. So we decided to not to do this initially. So if we do that of having public access and assigning the relationship to a user wildcard, we will return user wildcard without the excluded users. So we'll document that behavior, but we kind of remove this from the existing API. And then the other piece is we're working on performance improvements. There's a few scenarios in OpenFGA when we go to the database more than we should. So we would do more database reads than we should. And we identified it. We have some ideas of how to fix that. And in some cases, the performance improvement could be significant. In others, not, right? But depending on your model, this could be very impactful for you. And then, so we're working on this. Hopefully next month we can demo something. And this is what we have in our roadmap. So we always update it usually before this call, but sometimes sooner when we ship things. So we're working now in list users, in the additional consistency options. That is where we share search. And we're starting working on telemetry, tracing, and logs on the SDKs. That will give you, for OpenFGA use cases, it will be mostly about tracing. So if you want to know, I performed this call on the client, on the SDK, and that triggered, it's connected with this specific thing on the server, you can kind of have a trace of all the behavior to be able to troubleshoot issues, performance issues, whatever. And we'll also help you connect the log streaming from the SDK if you want to specific target and get the data from there. And then the performance improvements from check that we're working right now. And so we started working on integration with Envoy that we will also, and then we also have a story with Istio there. That is something that we are also building and hopefully can help in some use cases. And the other things we have discussed in the past, one is integrated FGA for authorization for FGA calls, and also helping on the search with permission scenario for large cardinality. We kind of paused that work because we wanted to focus on performance, and then we're going to go back to that work stream later. Any comments or questions about this?
I think Jigar had a question.
Yeah, go ahead.
I had a question about the consistency options, please. For the higher consistency option, the demo that you gave, that was about G-Drive. What would be the use case if my caching was enabled? When would I want to go for higher caching, even though I made a conscious decision to enable caching?
Yeah, it will be more for higher consistency, right? So you would say
Right.
There's a specific use case where I really want to skip the cache because that one, for whatever reason, it's important that I will have the latest
Right.
one, right?
Oh, sorry,
Right.
that's what I was trying to learn. Like, have these use cases come up? Like, I would be curious to know.
Yeah, so yes, and this is for checks and for reads for everything, right? That we could cache, and sometimes there are scenarios where you kind of share something with someone and you want that to be immediately available for the user, right? I don't know, I share a document with you, send you the link, and you want to click it and view it, right? And it might happen that if the shared value was cached, then you don't see it, right? So there might be some scenario with that, but that is very application specific, and and depends a lot on what you do. Yeah.
Yeah, I think we will use it. Actually, we have a use case. For example, in our application, sometimes we want to insert tuples, and we don't need the data to be ready just after we inserted it. For example, we can remove a user from a group, and it's okay if it's not available in the minute. We can wait 1 minute or 2 minutes. But we also have like an interface when we can manage a user right directly. And when I change a right, just after it will be refreshed, so I can see what I've just done on the interface. So in this case, I will want the consistency and not the cache. So it will be a great option for us, for sure, and we will use it as soon as it will be released.
Awesome. Chris.
It's just a quick one. How come we would go down the route of higher consistency instead of invalidating the cache?
Can you repeat? Sorry.
Sorry. How come we can't just invalidate the cache when a change is made? If changes aren't made regularly in a system. I mean, obviously, larger systems probably change regularly.
In this case,
they may. Yeah.
So you can invalidate it on one node. We don't yet have like a cross node cache where you can invalidate from all the nodes.
And it's also another issue, which is here is like it's not that we are kind of writing a tuple and then reading that tuple directly and we can invalidate it. It's more like what we're caching as the result of checks operations, right? And it's not trivial to know a specific write where all the checks that the writes imply. That is kind of quite expensive to calculate, right? So it's kind of difficult to do that invalidation automatically. At some moment maybe we figure it out, right? But right now it's not possible, right? So we don't know what are the checks that are impacted, check results that are impacted with a specific write directly. Right?
No, that makes sense.
Okay, good. So community news, we're going to be presenting in Seattle in SecurityCon by the end of this month, in a couple of weeks. And then we'll also be presenting in Open Source Summit in Vienna in September. And Jose Carlos works for Okta, is not part of our team, but he submitted a presentation to show how you can use OpenFGA for fine-tuning authorization, and he was accepted, so we're going to be there. And we're going to have a survey. We did it last year. The community was way smaller, and we get a few responses. Hopefully this year we get more. And this will be, you get a link, is mostly about to understand how you're using OpenFGA, what has been your experience, and things like that. So it will be great if you can answer it and help us learn about what's going on in the community. And then I've been mentioning this the last few calls, but please join our CNCF this Slack if you haven't. That you can go to Slack cncf.io if you don't have still an account in their Slack, and then interact with us in the OpenFGA channel. So that's it. Thank you very much for staying a few more minutes. Thank you, Mark and Maria, for your LXD presentation. It was very insightful for us. So we'll follow up with some questions, and hopefully we'll see each other in a month. Let's see you. Bye-bye.
Thanks a lot. Bye-bye.
Thank you.
Bye-bye. Thank you.